Okay, so today we will be discussing using or choosing a statistical test, which is obviously the most horrible part of stats, and this is very high yield. We got a lot of questions regarding this section, so let's start. So before using or choosing any statistical test, we should have a few questions in our mind, and obviously the answers of those questions. What are they? Question number one: how many variables do we have? For example, univariate, bivariate, or multivariate. Do we have only one variable, two variable, or multiple variable? Because obviously, on the basis of this variable thing, we'll choose our statistical test. Okay. We all know that what is variable. So I'm not going into the detail of that variable and data. Then we have a next question, which is how many groups do we have? Do we have just two groups or just one group? Okay. I'll explain the significance of this thing later on. Is the data parametric or not? This question is the most important one. Okay. If we have the parametric data, then we will use different test, and if the data is non-parametric, then we'll use different test. Number four, again, very important question, and we should have the answer of this thing, which is independent observation or not. Do we have a paired observation or independent observation, right? And finally, we should have an answer of this thing, that what are we measuring? Are we measuring mean? Are we measuring frequency? Okay, so let's start with our first family. Okay, we have a family which is t-test family. In this family, we have two types of t-test. We have student t-test and we have paired t-test. Okay, the student t-test is basically unpaired t-test, and paired t-test, it is self-explanatory that it has a paired observation. So again, on the basis of these questions, let's answer. We will use students t-test when we will have data univariate, one variable, when we would have two groups, when we have the parametric, then we have the parametric distribution, normal distribution. Okay. Then we have independent observation. If we have two groups, we are measuring data only one time. We are not, doing a retest. We are not doing a paired observation. And if we are measuring mean, if this criteria fulfills our question, then it means that we will have to use the student t-test, which is unpaired t-test. I'm not coming into this line. I'll come back to this later. Okay. The second test in t-test family is paired t-test. What is paired t-test? It is again we will use when we have one variable, when we have two groups, when the observation is parametric. The only difference is that here in a student t-test we would have independent observation. Independent observation means we have unpaired observation. That means we are measuring two groups at only one time. But here what we will do, we will use the test retest thing, like paired observation. Okay, we'll the pre-test and post-test thing. For example, we have a group and we measure it before anything, and then measure again after the anything. So it is paired observation, test retest. Again, if we are measuring mean, then we will use. If this criteria fulfills, that means you will have to use the t-test family, and on the basis of this independent and paired observation, you will decide should you use student t-test or paired t-test. This line is very important. If the data is non-parametric, which means that we are measuring median. See, we have different types of data, right? What are the types of data? Continuous, okay, the data which is nominal, the data which is ordinal, and all those type of things. Okay. So if the data is non-parametric, always remember that parametric means we are measuring mean. If the data is non-parametric, that means if we are measuring median instead of mean, then the student t-test alternative would be Mann-Whitney U-test. Okay. Similarly, for paired t-test, if the data is non-parametric, okay, non-parametric means we are measuring median instead of mean, then the paired t-test alternative would be Wilcoxon. Got it? Moving on. Then we have another family, which is F-test family. We also call it analysis of variance or Anova, right? Now see, Anova, you must have came across, 1 second, guys. Let me silent my phone. Okay. You must have come across this term, ANCOVA. What is ANCOVA? ANCOVA is ANOVA, but if ANOVA is used for adjusting confounders, there are different tests which we use to adjust the confounders. For example, mental Hansel method, ANCOVA, and all those tests. Okay. So if ANOVA is used for adjusting confounder, then it's ANCOVA. But this has nothing to do with the choosing a statistical test. This is just an additional information. Now, ANOVA is also known as t-test family. ANOVA is known as f-test family. Okay. ANOVA test tells you if we have a difference in the group, but it does not inform where does the difference is actually present. That is why we have t-test family, because it tells you where does the actual difference lie. So if you are using ANOVA, you can use t-test and vice versa. Okay. ANOVA would tell you that if you have a difference in the group, but it will not tell you about the actual position or the actual presence of the actual position of the error or difference, and t-test family will tell you about the actual difference. Now, if you can use ANOVA, you can also use t-test or vice versa. This line is very important because we do have an MCQ regarding this line. Okay. Now, what are the types of, how many tests do we have in ANOVA and family or F-test family? We have one-way ANOVA and repeated measures ANOVA. One-way ANOVA is used when we have univariate test, when we have more than two groups, when we have parametric distribution. See the difference. Previously in t-test, we had two groups. Here we have more than two groups. Again, the distribution should be parametric. This should be independent observation and measuring mean. In repeated ANOVA, it should be paired observation. It should be paired observation. Am I audible?
Can I ask you a doubt?
Yes, please.
Is it for two or more groups or only more?
We were talking about ANOVA. We have two different types of ANOVA, one-way ANOVA and repeated ANOVA. One-way is used when we have univariate, that means one variable, and we have two or more than two groups, parametric distribution, and independent observation. On the other hand, in repeated ANOVA, we would have more than two groups. It should not be univariate. Repeated ANOVA. Repeated ANOVA means we have multiple variates, parametric distribution, paired observation, not independent observation, and it should be measuring mean. But if we have a non-parametric version means it is not measuring mean, it is measuring median. Okay, ordinal data. So in non-parametric version of one-way ANOVA is Kruskal-Wallis test, and non-parametric version of repeated ANOVA is Fredman. Okay, this is just to remember. Moving on, we have a chi-square test. Chi-square test, again, if you see here, our main questions, it was saying that mean or frequency counts. So we are done with the mean, and now we have a test which measures frequency, which means category, which means proportions, which means we have categorical data. Okay. So for this, we have 2x2 table, and we have two versions of chi-square test. One version is called Fisher version, and it is used when we have the expected frequency in 20% of the cell falls less than 5 in one cell. Okay. Obviously, in 2x2, for example, we have 4 cells, and in one of those 4 cells, if we have a number less than 5, then we would use, or the value less than 5, we would use Fisher version of chi-square test. We have another version of chi-square test, which is McNemar version. McNemar version is exactly like a chi-square test, but it is used when we are repeating our measures. For example, if we are using chi-square test for 2 times in the same person, then it would be called as McNemar version. Okay. Now we are discussing correlation. Okay. What is correlation? Correlation means association. And in between, between what? Between the variables. Okay. Correlation, always remember that correlation does not mean causation. If two things are correlated, that does not mean that one thing causes the other thing. Okay. Correlation can be positive, it can be negative, or it can be absent. Okay. I'll explain the ranges here, but let's see the example. If A increases, then B would also increase. That means we have a positive association, positive correlation. Okay. If we talk about the range is between -1 to +1. Okay. The range is between -1 to +1. Please, guys, mute yourself. -1 to +1. -1 means we have a perfect negative linear correlation. +1 means we have a perfect positive linear correlation. -1 means no association. +1 means perfect association, and 0 means absent correlation. Okay, absent correlation, negative correlation and absent correlation, we have a huge difference. Okay, I hope you know the difference. Okay. Then obviously we all have done our mathematics and we do need coefficients. So in correlation test, we have two types of correlation coefficients. Okay, these two correlation coefficients are Pearson's correlation coefficient and Spearman correlation coefficient. What is Pearson's correlation coefficient? It is used for, it is used when we have a normal distribution, a parametric data. Okay, and Spearman's correlation coefficient is used when we have non-parametric data. Non-parametric data. There are other few terms which we should be aware of, and these two terms are also, I would like to add one thing, that Pearson correlation coefficient is measured by R, means denoted by R, and it is denoted by rho. Okay, Spearman correlation coefficient, it is denoted by rho. Then we have some other terms which are obviously not related to this thing. One term is Cohen's d, which measures the effect size, and another term is Cronbach's alpha, which measures the internal consistency. Okay, what is kappa? Kappa is basically something which measures the degree of agreement, and it does not measure the degree of association. It measures the degree of agreement. For example, we have a scale, and me and my colleague applied the same scale on different people. My results were 7, 8, 2, 4, 12, and my colleague's results were 7, 10, 2, 3, 15. Where did we agree? 7, 2, 7 and 2. So this is the degree of agreement. Kappa is basically the degree of agreement, and the formula is actual agreement beyond the chance divided by potential agreement beyond the chance. But we should remember only one thing, that kappa is related to degree of agreement. What are the values of kappa? The value of kappa greater than 1 is good. More precisely, if less than 2.0 is then 0.20, it would be poor, and greater than 0.61, this value is considered as good. It is, I got these values from the book. Okay, so we are done with the correlation, and now let's move on to regression. Correlation and regression, we have a huge difference. Not actually a difference, but correlation is regression is basically a step further away from correlation. We should have correlation before doing regression. Okay, it does not only measure the association, but it also predicts the value of one variable from other using equation. Okay, so let me remind you that we have two different type of variables. One is dependent variable and one is independent variable. Dependent variable is something which is dependent on independent variable. Okay, for example, if we talk about, you must have heard about these terms like linear regression, multiple regression, and all those things, logistic regression. Let me make it simple for you. For example, if you talk about linear regression, okay, if we talk about, is it fine? Is it fine?
Yes, it is.
Okay. Okay. So we are talking about linear regression. The equation is y is equal to a plus bx. Now here, you should remember this equation. The y is the dependent variable and your x is your independent variable. I said one thing which was dependent variable means y is dependent on independent variable which is x. For example, for example, I'm talking about weight gain by using fluoxetine. So we have two variables. One is weight gain and one is fluoxetine. Taking fluoxetine. So weight gain would be our dependent variable because we cannot control. The main difference is that dependent variable cannot be controlled by a researcher, but independent variable can be controlled by a researcher. So obviously you cannot control the weight, but you can taking fluoxetine. Okay, so taking fluoxetine is your independent variable, which is x, and weight gain is y. Obviously, weight gain is dependent on your independent variable, right? But you can control this. You cannot control this. You can indirectly control this, but you can directly control this thing. It is very important to understand this equation. Y is your dependent variable, x is your independent variable, and this is called constant. A plus B. Okay, this is the equation for linear. Linear means bivariate regression. We have two variables, right? One is dependent, one is independent. Moving on, now we are talking about multiple regression. Multiple regression means the word suggests itself. We have multivariate regression. We can call it multivariate regression. Okay, what does it mean by multivariate? We have a dependent variable, which is y, and we have multiple independent variable. Multiple independent variable. Okay, and major sometimes these some of these independent variables, they are considered as confounders. For example, if we are talking about association between coffee and lung cancer, then smoking is a confounder. Okay, coffee and lung cancer, smoking is a confounder. So let's suppose this is coffee, this is lung cancer, and this is coffee. One variable is coffee. Dependent variable would be your lung cancer. So taking coffee causes lung cancer, but there are other confounders as well. For example, spending too much time in heavy traffic, okay, or smoking. These are the confounders. So basically, this equation, multivariate regression, is used when we have multiple independent variables. Now we are talking about logistic regression, which is also known as logarithmic regression. Why? What is this logarithmic regression? Logistic regression or logarithmic regression is used when we have binary dependent variable. Binary dependent variable. Binary dependent variable means that obviously this is the dependent variable y, right? This is binary. Binary means we have dichotomous variable. For example, here we have schizophrenia. So schizophrenia can occur or it cannot occur. Okay, we cannot say this is partial schizophrenia. The answers are yes or no. If it is schizophrenia, this is yes. If it is not schizophrenia, then it is no. So dichotomous variable. Logistic regression is used especially when we have binary dependent variable. Up till now, we have discussed that why is our binary dependent variable. Guys, mute yourself or I have to remove you. I'm really sorry because I'm recording this session and it is causing. Please mute yourself. Okay. So we were discussing that y is our dependent variable. Schizophrenia, I'll explain it later on. Okay. It is constant basically. A plus B is a constant. Don't confuse with this thing intercept. This is the constant. So, yes, schizophrenia is a binary variable and dependent variable because it is y. Schizophrenia can occur and it cannot occur. So, logistic regression is especially used when we have binary dependent variable. In logistic regression, we deal with the parametric dependent variable and non-parametric independent variable. This is just to remember, okay? And I can explain it that this means that parametric dependent variable, this dependent variable should have parametric distribution, and this independent variable should have non-parametric distribution, mean, median, okay, ordinal data. Non-parametric variables are the ordinal data, as I mentioned, the data which can be categorized. Now we have different multivariate techniques. Multivariate techniques are those techniques which we use to deal with the confounders. See, we have different steps in which through which we can deal with the confounder. Before in recruiting people, we have different techniques like randomization, minimization, restriction, matching. These are the techniques which we usually use to deal with the confounders before recruiting people. But once the people are recruited and now we are at the point of analysis, then there are different techniques which we use to deal with the confounders. What are these techniques? Mental Hansel method, multivariate regression, which we have discussed. Okay, Manova, which is ANCOVA, analysis of coefficient variance. ANCOVA means it is simple ANOVA, NV ANOVA, or M and Manova or ANCOVA. These are the same things. ANCOVA means the word ANOVA. ANOVA is analysis of variance. This ANCOVA means we have co in between ANOVA. This is this means confounders. So Manova, ANCOVA, or NV ANOVA. These all are same terms which are used to deal with confounders, multivariate techniques. Then we have different other techniques, for example, cluster analysis, discrimination functional analysis. The few of the techniques are very important as far as the exam is concerned. The path analysis is basically the chain of causation. For example, we do have a question regarding this path analysis in our high yield bank, that we have a depression and it is causing poverty causing low socioeconomic status, and this is leading to suicide. So we can say that depression leads to suicide, but there are other factors as well. So this is a chain of causation. This is called path analysis. If we talk about factor analysis means reducing the data and categorizing it to make it, just categorizing it or making it more organized and smaller. So this is your factor analysis. So this was all about